So, good afternoon to all of you, and welcome to this Digitalization in the Space Sector from Hardware to Software panel. Digitalization is a broad topic, going from the better integration of production line to the use of centralized digital models to facilitate system design, or to the increased capabilities on board satellite through the use of more sophisticated software. Industry 4.0 and its analogous Space 4.0 rely on the future of this digital transformation to increase efficiency, reduce costs and waste, facilitate collaboration, and more. We are here today to talk of this interesting topic with our panel, whom I'd like to introduce now. Starting off from my left, Cristina Janopapa. Dr. Cristina Janopapa is the head of political affairs for the European Space Agency, where she's responsible, amongst other things, for the parliamentary affairs and for liaising with member states. Welcome. And to her left, Mr. Dietmar Ratz. I hope I pronounced that right. He is the president and CEO of the space company GNF, a company with many years of experience in the field of attitude and orbit control sensors for satellites and optical instruments for Earth observation. To his right, Dr. Robert Axman, who is the head of DLR Program Strategy Space and acting director of the DLR Institute of Data Science, where he is responsible for the development of the research strategy together with the involved DLR institutes and the members of the board. To his left is Dr. Frank Dannemann, who is the head of the Department of Avionics Systems at the DLR Institute of Space Systems here in Bremen. And his research focuses on model-based, scalable, and intelligent avionics architectures for future space systems. And finally, a new addition that we only incorporated yesterday, so I apologize for him not having a shield in front of him. Mr. Berlin Barsk is a project manager for microsatellites in the Technical University of Berlin, where his research focus is on modular satellite platform architectures and lean development processes for small spacecraft. Thank you all for being with us here today. So, Cristina, could you please explain to us what digitalization is to you and your interest within it?
Sure. So thank you very much for inviting me to speak in this very interesting topic, and I would like to speak a bit about space and our digital future. Why do we talk about space and its importance overall? Because one day without space would be so much different than it is today. We would not be able to watch football, we would not be able to take money out of the ATM machines, we wouldn't be able to travel and come here to this wonderful city of Bremen. So space has become an indispensable part of our everyday life. It's everywhere and in different type of areas. So Space 4.0, you talked about it, and what is Space 4.0? It talks about commercialization, talks about the possibility of using different type of materials, different manufacturing techniques, digitization, Internet of Things, connectivity, anything, anytime, anywhere. So it changes quite a lot the way we do things. So the European Space Agency and the EU have actually sat together and decided in 3 high-level goals on how we should look into the future. One of them is integrating space into the society and the economy. The second one is to have a very European competitive sector and to ensure that we have European autonomy, and the digitization plays a role in all of them. So, space. It is not the only thing that provides data that can change the way we do things. If we combine space with air and ground information, then we have data, and if we bring them together, they become what is called big data. And if you go further to processing it, then you get products with information. And digitization plays a big role. And as we move along the chain, we go from institutional to commercial activities. So, how does this play a role? Well, it gives us endless amount of possibilities by combining this different type of information. It can give us information for agriculture, for water quality, for the different type of things in the area, for example, of agriculture. So space is as a tool for decision and policy makers in all different type of areas, as it can, with the digitization and information it provides, give them the possibility to make informed decisions in different areas. I will give another example, the area of maritime. The European Space Agency has recently signed an agreement with Rolls-Royce, who is envisaging to basically transform the maritime sector than we have it today, which will mean transform it in all possible ways, from designing boats, through combining different type of information, through navigating into the seas with automated vehicles, where basically a captain can be remotely somewhere else, or a captain can be on board a boat, but have the possibility to combine different type of data, satellite data, telecommunications, navigation, in order to know how to safely go through the sea and in the fastest possible way. So the digitization is transforming the way we can do things, and space plays a very big role. All of these things, however, have to be done by taking also into consideration the fact that we need to ensure that we have secure communications, and that is a very important element. And ESA is looking into a project called Skylight to ensure that we have secure communications. But we need to also keep in mind that there is a digital divide, and we need to bridge it, because when we talk about digitization, it has to play a role in all different types of areas when we talk about the space sector. The European Space Agency has set up what is called the digital agenda, when we try to integrate the digitization in various different areas, from the technology to the way we are communicating in all fields. So in the next couple of months, we will be preparing to go to our ministerial with 4 thematic pillars on science and exploration, safety and security, applications, enabling and support. And in this way, we are considering that digitization should be across in all areas. So with that, I would like to thank you for the opportunity to be here and discuss with you and the other panelists.
Thank you for being here. So Dietmar, what is your view on the topic? What is the industrial perspective on digitalization?
Yeah, thank you for your warm introduction and for the invitation to this panel. Yeah, I'm looking forward to discuss this topic with you, but I have to make a statement. I'm coming from the industry, and we at the moment more analog guy, because we are producing devices. So we would like to touch this, we would like to see this, and we would like to have a feeling how they grow and what's the behavior in the test. But nevertheless, digitalization is a must for anybody of us, and Christian says this on a more or less complete way. But and we have yesterday even a great speech of Tom Enders. He was talking about the orbital society. So, and if you're looking in this perspective, of course, the IT or artificial intelligence is key for anything what we will do. And of course, maybe we at the moment are working on missions that makes possible to give answers how is environmental or climatic conditions in 10, 15 or 100 years, so, or what is possible with global communication, navigation, so, and even maybe we are able to civilize new planets, or what are the boundary or boundaries of our universe. So, and this is fantastic, and as I mentioned, we at the moment, yeah, in a change now, and even as industry, we are faced with this change, and we have to react to this. Of course, cost. Yeah. So cost, we have to find solutions. On the one hand side, we have to reduce the enormous cost for space activities, but at the end, our products have to survive in harsh environments, so that we have to find smart answers to this, but we cannot avoid to give answers. Then we are faced with a couple of new requirements for performance. Now, this is depending on the new missions. This is cool for engineer. So then the autonomy of our instruments, components, and mission itself are increasing. So, and we have even to solve this. This is even related to costs, but even to the functionality of our missions. Then flexible design. What does it mean, flexible design? Okay, requirements changing rapidly, and we have to find answers with a existing design to this. We have to reconfigure our systems, and this is even necessary to survive in a more rapid industrial or programmatical way. This is even a condition. Then we have different business models. Coming, maybe we have to deal, or it's a pleasure for us to deal with the agencies. So on the one hand side, on the other hand, we have new customers coming mainly from the IT branch. They give new impulses in our society, and this is highly welcome because of the support us for cost and all other things. So, but we have to find answers to this. And then technology itself, maybe communication. Maybe that's this nice image of the laser communication device from our colleagues from TSAT. But this is not the only one. We have to find new storage things. We have to find new autonomy, I mentioned this. And we have even to find now new possibility for Earth observation, for sensor itself. So, and to sum up, all this is just possible to solve this with digital tools. And so coming to another point, maybe if I'm looking in our branch, we have two branches inside of the space industry. One is we build satellites, and the other side is we have to operate the satellites. And in both these branches, Industry 4.0 is mandatory. In the first, to build satellites, we use this. Maybe we were not aware that we use this, but we use this. If I compare this to the requirements or to the image of this Industry 4.0, we develop with tools our devices. This is completely simulated in computers before we do the first hardware piece. So then we have to test this. If you imagine, all these tests take a lot of time. We collect a lot of data. We have to store this data. We have to archive this data. We have to handle this on a proper day. So, and even to have this data maybe after 10 years available, if there anything, any question arise. So, and on this way, on the other hand, we have even to cooperate, and we do this as electronic over the ocean with Japanese, with our friends in the United States, with colleagues in Italy or in Canada or in Korea. So, and that's why we are working more or less around the day. So, and we have to transmit complex data to anybody of them. They process this, they send this back, and the next morning we can go ahead. And this is Industry 4.0. So, but we have to improve this. We have to bring more attention to this. For example, 3D printing activities. This is a couple of new things. So then driving satellites. This is, I say, purely Industry 4.0. So because of, you can imagine all the satellites are autonomous robots. They're flying far away, and they have a high degree of autonomous. You have to control this. All this control is related to state-of-the-art communication, archiving and command systems, and even to collect all the data from the satellites is maybe, I guess, state-of-the-art, what we are doing at the moment of this world. But nevertheless, this goes on now. And if we're looking for all these missions that we have, this is not the end. And there arise a couple of questions for me. This is not solved at the moment. For example, I would like to bring this even to the discussion. How we handle all this satellite data and information. Can we standardize this? Or who takes care, especially for our European Copernicus system, for this data? So, yeah. Then what kind of artificial intelligence we use for processing and management and analysis of this data? And who will be responsible for the results coming out of this management and analysis from this data? So, and I hope that we can come close, maybe not in this panel, maybe this could be a good starting point, but in the near future to give really state of the answers, even from Europe, to come closer to the solution for this issue. Yeah, thank you.
Oh, thank you. So, Robert, what is the impact of digitalization in your opinion? What is the most important part of it for you?
Yeah, I think from my point of view, from the DLR point of view, it's for us interesting. The title of the panel is Digitization in the Space Sector, from hardware to software. And I think what's interesting, it's not going only to software, it's to more software. And what's for us, it's interesting, what are the driving reasons behind? And I think there are several reasons driving the future of software development. It's a continuously increasing amount of data that's produced by the raw sensors. I think, for example, for Earth observation, and we are doing a lot of Earth observation within DLR, we expect a growth of, let me say, around 500% coming within the next years, concerning the amount of data that's coming in to DLR to be processed. That's an interesting fact. We are developing new sensors like hyperspectral sensors, producing really bigger amounts of data compared, let me say, 10 years ago or 20 years ago. And another fact is that we are changing the way of transferring data on ground and also in space. Years ago, we relied on entirely S-band and X-band communication, and nowadays we are working with KU, with Ka-band. And now optical communication is coming up with increasing optical data transfer rates. And last but not least, also the production chains. So for example, Jenoptronic, they are going to digitize all their production chains, the qualification of the components. Every process, every step is producing data. So that's the reason for the growing amount of data. And then it's a question, what can be the answer, or what should be the answer to this? And it's not just for the future that we are going to develop clever mechanisms to transfer the data, to store the data, to process the data, for example, already within the storage system for bigger amounts of data like weather data, Earth observation data, but also, that might be interesting for the future, to do in situ science already, processing onboard a rover, processing onboard a satellite, decision-making onboard a satellite. I think that might be an answer to already, let me say, avoid or reduce the amount of raw data to be transferred. Very interesting subject. Yeah, that's my statement.
Okay, thank you. Frank, so what are your thoughts on the topic? We're having some sound issues.
My view on the topic is a little bit biased from the world I'm coming from, as I'm working in the avionics sector, so very closely to hardware as well as software. I would rather rephrase the topic of this discussion panel from hardware to software, more to better and more powerful hardware, and better software enables more capabilities for future space missions. So it's not, from my point of view, it's not a shift from hardware to software, but with a kind of a close relationship. To make this, put this more into, give them some more details. So you have, let's say, today we have more and more space processors, space embedded architectures at hand, which have a lot of computational power, which are reconfigurable, module, and so on. So we integrated these new technologies into our current satellites, and with this technology we have completely new possibilities. And what is a little bit lacking behind is the software. So of course we have the classical software applications which control the satellites, do the onboard payload data processing and everything you need to transfer it to ground. But now with this new hardware available, we can think about completely new possibilities. For example, as Dietmar already said, artificial intelligence is one of the buzzwords, let's say, for the time, with everything related. And now, with this hardware available, we can think about, for example, bringing techniques like neural networks, like deep learning, really into space. If you look at the the past. These techniques are more or less earthbound, so there's a lot of analysis ongoing with telemetry data from satellites. There we have this kind of new techniques like deep learning and neural networks and so on. And this is more, let's say, in the operational world. And now the challenge is, with this new hardware available, to really include it into future missions. For example, just on the 3rd of October, we had this Mascot landing on Ryugu. Mascot has an autonomy manager on board, which is more or less hardwired. So there are predefined decisions programmed in the Mascot satellite for future missions to Mars and beyond. We can think about think about self-learning systems, systems that you can send to completely unknown environments, which are pre-trained to react to unforeseen events there. So, and this is really a mission enabler for deep space missions. It will, on the other hand, also lower the cost for all this low Earth orbit missions, so more autonomy on ground as well as on the spacecraft, lowers operational costs. Lowering operational costs again will result in completely different missions. All these missions nowadays with these constellation missions, OneWeb and so on, they all need a completely new operational scheme. You cannot really operate each and every satellite as a single satellite. These constellations has to act autonomously, and yeah, from that point of view, digitalization means, from us, from the avionics point of view, really a shift towards a high increase of autonomy, artificial intelligence, onboard embedded systems. Yeah, that's my view on the topic. So challenging times, interesting times. We now have the technologies in hand. We just have to bring them together and really bring them into current missions. And that's what we are going to do in DLR, because we are on the, let's say, we are in the research sector. That's our purpose, to take this basic technology and bring it into practice, and then working closely together with industry and industrial partners like Airbus and OHB and so on, to really enable new missions, deep space missions, for example. And also want to work together with universities, of course. So, okay, that's it.
Thank you, Frank. So, Merlin, how do you, from your side, see digitalization, or what part is more impactful from your point of view?
Okay, a few words from a university perspective, maybe, and of course, a lot of things have already been said which are relevant to the topic. And also my view, of course, a little bit biased to the smaller end of the small-sat community, because this is what we do. But I think, as we all know, the challenges we are facing is that we have more diverse applications. We have more challenging applications in themselves, as we had before. And also we have, like most of the applications, like 24/7, which were before more like scheduled in time. And this, of course, requires new technology. And for us also, beneath the technology itself, a big challenge is like the processes, how to implement the technologies. And as we are working with hardware and software, which is even more like not meant for space as the stuff that Frank already mentioned, like really cell phone technology and things like that, the product cycles of this technology are so short that the processes we require to implement them for space, which are then they are not built for, and which is not like considered while developing them, need to be even more agile to make it possible to really, like Frank already said, to really exploit the new possibilities, and not just flying something which is up to date and fancy, but really exploiting what you can do with it. And I think this is seeing all the constellations and all the small satellite activity. I think, yeah, having processes which can really exploit these new technologies as fast as they develop in space is very important. And also, as Frank already said, operating these technologies. Like if you have 4,000 satellites, you don't you will not be able to have 4,000 operators like concentrating on one satellite. So there's a whole new level of very software concentrated work to do to make it possible to have some intelligence, some learning implemented into the system, so they can basically more or less operate themselves, and only particular instances are like overseen or corrected by human inventions, basically. And also what Frank already said is very important for us. It's not really, for us, not a shift from hardware to software, but we try to have a co-development of hardware and software, because most of the things that we see which are now possible are just possible because there's hardware which can do like very amazing stuff, and now we need the software to really exploit it. And if we wouldn't have this hardware, all the software would be useless, and this hardware is like basically for us defining the pace, how we can like develop new stuff and bring new stuff into orbit. So I think this is really important, not to shift from the perspective from hardware completely to software, and then you suddenly realize that you need the hardware to keep up with the development also. This is also what you see in your phone or something, like where the hardware is still defining a lot of functionality, is still defined by hardware and then realized by software. But it wouldn't work without the hardware, basically. So I think it's both together, which we should have an eye on. That would be a few words from the university perspective, maybe.
Okay. So one common thing that I'm listening to all of you state over and over is the bigger autonomy that these missions need, especially in exploration. How they are becoming more and more demanding, both the instruments per se, since they require more data rate from the communication side because of the huge amounts of data that they're producing, and how missions that want to be done also require this kind of increased information flow. And Dietmar even made a good question about how do we handle all the new digital information that we're generating just on missions, but I guess that also within other processes that are being in manufacturing and in development of the actual mission itself during design. I guess that is also part of what you were thinking. And we've heard Frank and Merlin talk about artificial intelligence, deep learning, neural networks on board. Do you see this as something that is coming up, that is already happening, something that has to happen, but we don't know exactly in what time frame?
I think I can start to answer. Let me say from DLR side, we are already on the way to move intelligence on board, to move more intelligence on board the satellite. So it's an interest since, let me say, also decades. But now we are seeing increasing computing power, as you mentioned, Frank, already. So increasing computing power is the prerequisite to get the intelligence, especially the neural networks on board the satellite. And we will see, I think, in the next years, within the next years, gradual a continuous increase in artificial intelligence usage on board satellites, Earth observation, but also exploration, especially exploration, as exploration is, let me say, relying a little bit also on the intelligence on board the planet or on board the asteroid to enable some experiments in that situation, because we don't have the fast contact within some milliseconds down back to the ground control center.
Or to see this with my words, the processing capability and the storage capability of state-of-the-art spacecraft so enormous that maybe I would say all scientific movies become true at the moment. We at the age that starts becomes a little bit hard for Hollywood to bring new movies on the market, because we do this at the moment. Yeah? So, and I'm proud that we're part of this. And the contents, the intelligence of missions becomes more and more important. Of course, this is the case. So, and this is good so, because of then the missions are flexible. Yeah, so we can control this from the ground. They become more autonomy. They do the right things by their own, because of we have sometimes run times and we approach to commits. Yeah, so we made this successfully. It becomes more and more I say it's not a routine, but I say we did this 2 times, maybe, so then as we'll go ahead, I guess. So this is in the space area, so I'm completely convinced we at this age, and this is, the door is open, and we went through in this years. So on the one hand side. The other, as I mentioned, from the production, we have an exciting project. We're producing, for example, optical components. So at the moment, we have with the institute here in Jena a project to come with 3D print technology immediately to a mirror system. This is so exciting. Yeah? I can't believe that we do this, but we do this at the moment, and we design this. We bring this design to the printing machine, and from this printing machine, the mirror system is growing up. Okay, we have to polish this a little bit, we have to reprocess this, but this is an enormous step. So you have a speed up of all design activities. You get immediately a feedback what you are doing, and you can bring this in a test, and this makes so many fun, even for the engineers, to see not after years what they are doing, so they have immediately the feedback. And this is a development, this is enormous. Okay, there are issues and problems, we have to solve this, that's why we are on this world. But at the end, this process is even started. So for software development, for example, more or less automatic software development started. So and so on and so on. So there is a lot of movement, and we have to take care how to collect this and to bring this in our development roadmaps. But nevertheless, the policies are more or less borderless, and okay. So that I fear a little bit, and this is my fear. That's why I said at the beginning, I'm more analog guy. We have to take care not to believe without any question mark in this technology. You have any time to make a break, to look back, and we are living as human beings in an analog world. That's why there are even dangers coming from this IT or digital world.
Yeah, so I would say that I would tend to agree that we need to have combination between hardware and software. They have to go hand in hand, because you have with the new possibilities of the hardware development, you have the possibility to match the software. The same thing as it is with a TV set. You buy a new TV set, you have a new hardware, new software that is equivalently providing you a better image. But I would say that in many areas, like many of us have talked about artificial intelligence, about machine learning, about all of these things, the big data problems, I think that we should not be in isolation in the space sector. We should learn from other sectors as well and make synergies in that, because there are other sectors like the biomedical sector or even the banking sector who have advanced quite a lot in the way they do this digitization and transformation. And not only from that, it is not only about the missions, but it is also about the processes. And when we talk about the processes, we can take as an example the Estonian government, which is an example of e-government, and everything is happening digitally. You go to the cabinet of their prime minister, and everything is paperless. The same thing we need to also adapt in our sector to ensure that we shorten processes in order to have a better and faster possibilities for the space sector in all missions.
And maybe I can add another point, because you mentioned it, artificial intelligence, for example, in other sectors. Also there, we have the problem of trust concerning artificial intelligence and their decisions, and especially in space, for example, space exploration or also Earth observation. If we move more artificial intelligence on board satellites, rovers, landers, we have to make sure that the PIs, the science community, is trusting the decisions of the artificial intelligence. It's not only what is possible by technology, it's also the trust. And it's not a space problem only, it's in general problem concerning artificial intelligence.
Yeah, yeah, absolutely. It's you see also with the medical field, with minimally invasive surgery, the surgeon is there to guide the robot, but is it really true? The robot knows quite well what to do, but you always want to have, for reasons of trust, the medical doctor. So it is.
But following on with this idea that you're discussing right now, it is clear that digitalization on its own would be missing a leg without cultural transformation in organizations and across organizations. So how do you think that organizations and the collaboration between them, how do these things have to be rewired? The organizations themselves, the way that they communicate with other agencies, to benefit really from digitalization and not just be one more trend that is. Any ideas, or maybe the industry can tell us?
The industry, of course, maybe we are quite open to take the best from all and to bring this to our activities, because of this is essential. So, and maybe we have this guys coming from the IT business in the United States, for example. So, and of course, they brought completely new ideas in our sector. So, and at first, anybody was shocked by what they would like to do. So, and this is not possible. And all this traditional discussions. Okay, but we passed this, and we opened, and we listened, and we try to understand what is their way to make business, how they act, and of course we have to transfer this to our business. You know? This is not to follow them blind. This would be not wise. But at the end, to learn from them, to be open, to be not, and we have to know that because of the coming from a more or less, I say, aristocratical position with our space industry or space activities, but become at the moment to a normal industry, normal. So, and that's why we have to be open. We have to be more or less polite to anybody. So we have to take the advices to transfer this to our activities, and this is what's happened at the moment. So, and maybe I guess the stress of the beginning is over. So, and now we try to work as hard as possible to acquire this new world. Yeah. So, and that's. So, Christina said, okay, maybe what are doing the people from banks? What doing this from medical applications? So, and to show and to learn and from each other, this is the way is what we're doing. So, and this is good. So, and that's why I hope even I heard this from the agent. They do the same. This is good. So, but we have to harmonize because of. Business with the agency is a little bit different to commercial applications. So, and that's why I take this with grant to statement, and I hope that even all participation to our scenario follow this way, because this makes sense for all of us.
Yeah, I would say that you used the word cultural transformation. Yeah. Mm-hmm. I think this is a very important element, and you said that we should not be in isolation. Yes, because things will happen anyway, and we need to be part of it. We need to be at the forefront of it. Mm-hmm. And for that, you have two ways that it has to happen. It is from the bottom, so to use it in all different areas, but also you need the support at the top from the management in order to promote the digital transformation. And these two things go hand in hand, together with the push that our sector becomes with the use of components off the shelf, with the use of things coming in a more commercial way, with things becoming cheaper and faster. We have this pressure. So there the cultural transformation is necessary to go also hand in hand with the management support, and from our side as engineers also to bring things forward.
Yeah, this is a good point actually. So your question before was how far are we away from bringing this into practice? So all these neural networks in space and artificial intelligence. I think we are just at the beginning. So now we are just at the beginning. We try to learn. We have a rough idea of what we can do with this technology. And we have to change the way now, for example, the project managers organize the projects and start their projects. We have to include it into new projects in a way that it is really it is a constituent which is there from the beginning on to really plan these new projects in a complete new way. Because otherwise we will just fall into our path and commanding the satellite classically, defining the whole avionics concept in a very classical way, and think, okay, this is just an advanced technology, maybe it will be mature enough in 10 years or so. We have to include it into really from the beginning on in current projects and have a financial corridor for this in order to bring this into practice. So otherwise we will have a kind of a niche somewhere and define a cool technology which will be used in 10 or 15 years or so. So we have to really be fast and change the way the project manager think as well as the payload guys think, for example. So also the payloads are thinking in a very classical way nowadays. They think, okay, we do maybe a rough pre-processing on board, but everything else will be done on ground. So because only on ground we have the capabilities to use these new technologies. If we tell them from the beginning on, for example, Antonio, you know it very well in the concurrent engineering studies, phase 0, phase A, place some hardware guys there and tell them we have completely new possibilities in order to take care of your payload processing. If you, let's say, save some money in the project for this kind of technology, maybe we can find a completely new way of operating your mission or doing this mission. And this is quite a challenge. It's a challenge for all new technologies, but especially for this kind of fancy technology we have there in the artificial intelligence sector.
Yeah. And if I may add a little bit, artificial intelligence, it's usually developed by people who studied informatics. And those people are really agile. They are developing fast, doing a lot of experiments, trying new packages for machine learning. And let me say, the engineers and the space community, they're working in ECSS phasing styles. So phase A, phase B, and so on and so on. So everything is really clear concerning the way the things are going. And it might be a good idea for the future to think about, let me say, more or less experimental artificial intelligence exploration or Earth observation mission, something like that, to foster the technology development and experimenting. It mustn't be the million or billion-dollar exploration missions. It might be a good idea to define artificial intelligence experimental missions just for the purpose of artificial intelligence.
Okay, but expanding on that.
Maybe there's a small thing I could add. I mean, at a university you always have the opportunity in smaller teams and to do stuff other entities here couldn't do, because we use a lot of processes, for example, most of them swapping over from the software development industry, which we can just use because we know that they're good, because they learned it already in the lectures, and we can just do it without asking ECSS or anything. So that gives us a lot of freedom, but then on the other hand, the problem sometimes is that it gives a lot of freedom then, and then there are so many possibilities to do stuff because it's not defined anymore. So you don't have this framework anymore just to do stuff how you did it before. So you have so much freedom that it's, again, a problem to somehow give it a framework, and also to give it a framework which you can use in further missions as well. And I think what you now often see is a lot of smaller entities which build amazing stuff, but they do it proprietary, and nobody knows how they really do it, and then it's gone if they're gone. So there's not this framework like ECSS anymore, which can tell everybody how to do it, and then everybody can process in parallel. So I think it is like, the challenge is that it is possible to open up a lot of different opportunities, but now we have to fill them somewhere with a framework so everybody can really use them. I think that's, it's not that easy to find the right balance there. Because in the end, of course, you want to reach somewhere and do something. At least that's our experience at this point.
Okay, but based on this conversation that you're having right now, we can see digitalization in different areas, right? We can see it in the design phase, we can see it during the manufacturing phase, we can see it in the operational phase. So we're going all over the design phase, the value chain. And my question to you, to the whole panel, let's see who comes up with a good solution to this, is how do we go integrating these different elements? Because as Robert was saying, right now we have, especially in space, here in Europe, we have these very clear-cut phases during design and then during production. And how do we integrate all this? Is it, I mean, the answer can't always be artificial intelligence. We have to have some human intelligence in there too. So what is the way that you see that?
Good question, because of, as I mentioned, maybe, maybe I like the idea of artificial intelligence, for example. So this is for engineer exciting, but for social people, that I said, okay, we have to collect experience with this, and even in the frame of space activities. Maybe I would say, for example, we have a great space system. This is a Copernicus system that collects data from anywhere and any time of our Earth. So, and this makes the complete Earth planet transparent from the atmosphere, ocean to the land. But at the end, maybe we have to think this over decades. So then increase the value of system. So to collecting data, to process this data, to work with this data, to make decision on hand of this data. But the amount of this data is so enormous, so that I cannot believe that we can do this by hand. We need algorithm, we need artificial intelligence to do this. But what happens with the decision coming from this not man-made intelligence? So politicians or other people made decision on this results of this analysis. Can we rely to this? Is this stable? Is this not stable? Is this valid? Is it not valid? And that's why we have to collect experience with this, and we have to find a roadmap to do this step by step, to become familiar with this, to teach us and this new aspect in our social life, how we interact together. And that's why maybe the question, the answer to your question, so you have to adapt this to any different process. For example, in our company, at the moment we're suffering with a planning tool because of, the people put data in, so in the planning tool that, the device is at this time ready. But if you make a Plausi check, that, we can be much faster, but our tool said, no. And the tool started to control and kick off activities inside of our company. And so, and at the moment we are in an equal process to adapt this, to learn how this tool react to our inputs and how reliable and how valid this outputs of the system are. But at the end we need this because of we would like to be faster, we would like to be paperless, we have to streamline our processes. There's no way out to avoid this, but at the end we have to learn to interact with this. And that's why there are so many different aspects. So, and we have, at any level and stage, we have to learn how we interact with these new possibilities that the digitalization gave to us.
Okay, so I think we are running out of time. We would like to give 5 minutes for questions from the audience. If anyone has any question.
At the very back.
Hello, thank you all for this very interesting panel. I have a question about the modularization. So all of the panelists have mentioned in some way that there's this trend towards the modularization of hardware and software, which is of course very beneficial because since each module is independent and self-contained, they can be developed by teams without interacting with the the other teams and test it independently as well as a whole. But it seems to me, as a computer scientist who's now studying space, that there's no common interface for these modules. So if I'm a student working in a CubeSat, I might want to use a cheaper sensor, and then once I've proved my concept and I have lots of funding, I can go to Gen Optronic, for example, and buy a really good sensor that has the same interface. So my question to you is whether you're aware of any effort to sort of standardizing the interface between the different parts, the different common components of a satellite.
We have an echo here a little
A
bit.
little bit.
The
yes.
last-
Could you just repeat the end of the question?
The end of
I
the
think
question
that
was how to
was
understand.
Sure. No, I don't have it.
we have a bit of a-
Hello? Okay.
Yeah.
So my question is whether you're aware of any effort to standardize the interface that common spacecraft components have, for example, sensors, gyroscopes, or cameras, or anything like that.
Okay, if you're aware of any efforts to standardize the interfacing between these elements.
Maybe this is for us, maybe we are producing components. This is a dream for us to have a standardized aspect in the industry, but unfortunately this is at the moment not the real case. But I'm convinced that our customers going in this direction because of maybe this is any time a debate to reduce cost, to stabilize lead times, and that's why we have to reduce the interfaces, we have to come to common designs. And I know, for example, maybe this is colleagues from DLR can explain this by themselves. There is an initiative inside of the DLR Institute for System Technologies that they try to find a good way to handle this even in this beginning of the design phase, to have digitized design tools to find a good envelope for different devices, different subcomponents for a satellite, and to reuse this as much as possible and to make space technology easier.
So for CubeSats, I think you are from the CubeSat sector, right? Or
I'm a student, so yes.
okay. So for CubeSats, we already have kind of standards, and this is really one, let's say, this we want to transport into the area of small microsatellites and bigger satellites as well. So together with ESA, we are working now for over 10, 15 years in what we call SAVAR initiative, Space Avionics Open Infrastructure Initiative. There are a lot of working groups dealing with standardization. And we are currently always in fight with industry, I have to say this. For example, regarding the standard on the common backplane for satellites, for example. There's always, of course, everybody agrees upon, okay, such a backplane makes sense, but industry doesn't want to have it because it makes components exchangeable. This makes things hard, but we are doing progress, very slow progress. But coming back to the maybe coming back a little bit, don't know if this addresses your question, but coming back to the topic of the panel here, digitization, how can digitalization help maybe coming to better standards and faster standards? What there's currently within the frame of the SAVAR initiative, we have, for example, just as an example, we have this electronic data sheet working group. So, and electronic data sheets are, okay, they are there. If we start to design a new satellite, no matter if it's a CubeSat or whatever, for example, in our design facilities, we still use these kind of PDF-based information sheets for every device. We are currently working on integrating these data sheets in a common data model, and there we come back to model-based system and avionics engineering also. We just had several weeks ago a use case at our institute where we started to using this electronic data sheets, integrating them into a common data model, and then the engineers had from the first day on this information at hand about a lot of devices they can use, a lot of sensors, a lot of actuators, and with this, of course, you need to have some kind of standardization in order to really integrate this information into these electronic data sheets or put it into these electronic data sheets. So even there, we are at the beginning, at the starting point. Let's say we need more standardization. I agree with you. It's hard to do this with industry sometimes because it makes components exchangeable, but. Yes, so we have some standards for some technologies. Of course, we have bus standards, we have backplane standards, but we need more of them. And really bring them into practice. Not only having the standard at hand, but really building the satellite using only, for example, SpaceWire and forbid everything else. That's what I said to ESA constantly, actually. Be more aggressive to industry, yeah? Adhere to one standard and one interface, sorry.
Okay, thank you. So the name of this initiative is Space Avionics Open Infrastructure. So I can look for it later. Is that the name?
I actually didn't understand. Could you repeat?
Sorry, yeah, it's a little bit hard to hear. Is the name of the initiative Space Avionics Open Infrastructure?
Is the name of the infrastructure is Space Avionics? Space Avionics?
So I'm just trying to remember the name so I can look it up later. Space Avionics Open Infrastructure, is that what it was called?
The
Of the initiative.
The initiative, it's savoir. It's called Space Avionics Open Interface Architecture. You can just Google it up there, and then you find a nice ESA page. And on this ESA webpage, you have all the working groups dealing with onboard computers, onboard software, mass memory units. For example, we already have defined several years ago a standard software architecture. We have an onboard computer architecture. There are other standards as well for mass memory and yeah.
Okay.
Thank you
very much. We have unfortunately run out of time for our panel today. So I would like to thank our panelists for being here and giving us their time, and to you for accompanying us. Thank you very much.